All right, went through my office. I'm like, hey, I do have a rotocoil. Here's a rotocoil.
It spins.
Push on this part, push on that part, it still spins.
It's the rotos.
Look what else I found.
Ooh. They look dirty.
What is that?
Sludge tubes.
Sludge tubes with
Sludge.
authentic sludge. Feel free to open the bag, take out the sludge, play with it, make a little sludge snowman with it. That sludge is at least all dried up. Normally it's not. That's for later time. All right, rotating devices. Rotator caps. All right, I'm looking at my notes. A lot of redundancy now. Intake valve. Already talked about that. What are they cooled by?
Air.
Yeah. Cooled by fuel air mix. Fuel air mix coming in. Has a larger head than the exhaust. And that's because it helps what? With what?
Volumetric efficiency.
That's the word. And how many degrees is it?
30.
Usually 30 degrees. Unless it's old, then it is. Yep. F. Valve dimensions. Well, I told you I always check the stem. And if the stem is usually that's the first thing that wears. But you are supposed to check it with a radius gauge. So, let's put this one. If reused, check with a radius gauge. And if you used a radius gauge in this area right here, you would know that if it's good or bad, like that would be a bad radius. I'll put these aren't in my notes, but I always measure the stem. Measure the stem. That's a critical dimension to me. And that's usually going to wear first. And then also measure margin. All right, this is 7, but way out there, 7. Valve guides. I wrote a lot of stuff in here about valve guides, and I kind of feel like I need to pull it back just a little bit. Maybe some of it's a little too much. So, installed into the guide boss. And that is an interference fit, meaning that the valve guide itself is actually bigger than the hole it goes into. Interference fit. Intake made of various softer alloys, exhaust made of harder alloys. You want me to write that stuff? I guess I took the time one day to do it. Intake. Softer alloys like bronze or brass. The exhaust is much harder alloy, very hard. There's steel, but it's a steel alloy. Resist, I think, is one of the ones they use, which has a lot of Ni. What's that, nickel? They'll wear out your tools pretty fast. This is a good one. I want to write this. Make sure to match valve and guide by manufacturer. So there are different manufacturers. Back when I was doing this, we had the factory, which would be either Continental or Lycoming. You had Superior, which I could do this. Had Lycoming. So there'd be factory. You had Superior. You had ECI. ECI was bought out by, I think, Superior or something. So factory at Continental. So Superior, they had their part numbers. Like a Lycoming would be an LW something. Superior was an SL. Continental was an SA. That's how you could tell Superior. What the heck was ECI? Sure, I was going to write it. Now I don't remember what it was. It's been so long, I don't remember. But anyway, they had their own part numbers. So the point I want to make to that is you couldn't just take, like if you were out in the field working, and this is where it would bite you, you're like, whoa, we got a burn exhaust valve. Well, that's okay. I'm going to take out the exhaust valve. So you take out the cylinder, you take out the exhaust valve, and then you ream the guide, and you're like, okay, the guide is fine. It wasn't too big, so we're going to accept the guide. I'm just going to order a new valve. And so you just order a new valve. Well, they aren't really compatible necessarily. So each manufacturer kind of had their own idea of which materials and metals they wanted to use. I've never heard of anything really failing in a catastrophic way by mixing and matching. I think it's just the longevity is really short. You end up redoing it. So you absolutely, whatever I used, whoever made the guide also made the valve that I put in. And it was just really rare that I would ever change out a valve without the guide. I just had all the equipment. It's just so much easier, and it's just wham, just change them both. What?
So if you had a Continental engine with obviously Continental valves and everything in it,
Yeah.
could you just go to Superior, say, hey, this is the engine I have. I want your parts
Yes.
for this engine. Okay.
Did all the time.
Okay.
In fact, towards, when I first started, I used mostly Superior stuff, and then I worked my way and I used mostly ECI stuff. So yeah, I'd be working on a genuine Continental cylinder, and I had to pull the guides and put in a new valve in it. I would just call ECI and order valve and guide.
Okay, you just tell them the original part number that was in there, and they'll match it with their own.
No, at that level, they kind of expect you to be ahead. So you don't necessarily, I guess you could, but they get a little irritated. I knew the part number. You have their parts guide and their sheet, and you just order it up. Just order what you want. Where was I here? We can skip that one. Must be changed with proper equipment and tooling. I've seen people change it. I'm gonna put this one. Alignment. Alignment is critical. It's like where to start with this one. There are so many ways to screw up a cylinder. So we just talked about roto coils and rotator caps. And on Continental, those rotator caps, rotor coils, they go on both sides. They want both of them to spin. Lycoming, you have a rotator cap on the exhaust and on the intake. A lot of the newer engines, they have it on both intake and exhaust. So manufacturers go through kind of a lot of effort to make sure that these things rotate. And so I've been out in the field, and people have their own ideas. And so one of the things that I've seen people do is they take their I'll try to move this where you guys can see it, their rocker arms, and they'll grind them on a cant. And so why would you do that? Well, that way when it comes and it pushes down on the valve, it gives a little spin to it. Yeah, no it doesn't. It pushes it over like that. And so what does it do to the guide? It wears it out like really, really fast. And this is kind of a pet peeve I've always had with our aviation engines and even the whole system about the alignment of everything. So if we count the alignments and we look at it, it just gets crazy. So first you've got a guide boss. All right, you got a guide boss. That's the hole that's cut in the cylinder where the guide goes in. Okay, completely separate from that, we have the seat boss. Okay, those two have to be cut perfect, but who knows, right? Then you're going to install a guide, and that guide has got some depth to it, obviously. And so you've got this pre-ream. So the guide boss, or the actual guide itself, has to be bored straight, but then you've got a seat that goes in here, and that guide that's been reamed out here has to be perfectly centered between those two that have been bored out. So we've got 1, 2 alignment problems already, right? We should have left more room up here. All right, so then we've got let's take a look at the top of the head. We've got 1, 2, 3, 4 bosses for the rocker shaft. They have to be, no, they're not as critical, but you've got the rocker arm, which has a bushing in it, which has to be done. And then you've got, so the valve is in there, and here's the valve tip right here. And then on top of that, we've got the rocker arm is going to come down, and that's going to press on that. And so we need this to be square against that valve. I can't have it hitting like this, or it's just going to push the valve over and wear it all out, even though I've seen people do that. All right, so you have to have all of that down. But here's the problem, and that is that you cannot reface this seat, or you cannot reface the rocker arm pad. And this is a funny story now, but stop me if I've told this to you.
Did you say you did that?
Yeah. So, it's one of those things in my shop. I told you we got all the equipment from this other place. We hired this guy. They came over. He worked for us for a couple of years, and he's just going to leave the company. So I move in the cylinder shop, and he shows me how to do it. So I'm doing it just like I was taught. And this is all very specialized equipment that, in some ways, the manual tells you how to change this stuff, but it really doesn't tell you to use the equipment, right? So it's mostly learning about using the equipment and getting it right. So, get it all done. And then, out of the blue one day, the FAA calls up and says, hey, are you refacing your rocker arm faces? Yeah. I'm not ashamed of it, of course. Yeah, it's, we're allowed to do that. Where do you get that data from? It's in the manual, isn't it? So I don't know, Kevin. I can't seem to find it. Why don't you call me back when you find it? Sure, it's right there. I mean, how could you have missed something that easy, right? So I go through the manual, and it's not in that one. It's not in this one. It's not in that one, or that one, or that one, or that one, or that one. I'm kind of panicking a little bit. So I start calling some other engine shops because, we're all in this together. And I'm like, hey, it's Kevin over at Air Repair. Hey, what's up, Kevin? Hey, do you guys reface rocker arms? Of course. Where's the data that allows you to do that? Same answer. Well, it's in the manual, isn't it? Like, it's not. Shut up. It is too. Yeah, I swear, man, I can't find it anywhere. Wow. Well, I'll call you back. And they call back. Hey, man, we can't find that data anywhere. What happened? I tell them, oh, crap, man, we're doing it too. And this went on for like a week until I called ECI, who I mentioned, and that was, they did a lot of machining work for us. We bought a lot of their parts, and, the guy's name was Tim, man. You guys reface rock arms? Yeah. You know you're not supposed to do that, right, Kevin? Like, well, I do now. Like, well, you guys do it? Yeah. Well, how do you do it? Well, we have op specs, engineering data to do it. Well, can I have that? Yeah, you can have that. So, they send me all the data, and I call the FAA. I'm like, okay, so here's what it is, and I explain the whole thing. I said, now I have this. He's like, good, I'll give you about 1 week to get that approved before we send a violation your way for doing unapproved stuff. So I'm like, whoa. So, having written the op spec, now I know the problem is people tend to grind these rocker arm feet, that's what I was looking for, and they overgrind them, and they were nitrided at one point, and you go through the nitriding, so you get rid of the nitriding, so they're not checking the hardness. And the other thing is that, what's the other thing? The surface finish was not, there was no standard, so we had to set specs for checking the hardness we were done and checking the surface finish. It wasn't that big of a deal. But I tell you that to tell you, in the industry, what the manufacturer expects you to do, Continental Lycoming, is to take these rocker arms. You can push out the bushings, push in the new bushings, which I hated doing Continental. Continentals, you push in the bushing and you have to ream it, which sucked. But Lycomings were easy. You push it in, you use that broach. Remember I told you about the broach for the conrods? You broached them to size. You're done. Just push the thing through, done. Next, push it through, done. It was easy. Broach to size. But then you're expected to just throw it back on the cylinder. Like, well, there you go. What's wrong with that? It's perfectly fine. And you know, when you look at these feet and they're just tore up and they're rough and they've got indentations and there's just no data for doing anything. It's like, well, they just want you to replace them or something, but you know, it's horrible. And not only that, you get, you know, like I said, massive misalignments here. So I did take advantage of the fact that I had an op spec and I was allowed to do it. So then I went and I customized our rocker arm facing machine, which just goes on the valve refacing machine. But I made it so that there had little set screws in it so I could angle it. And so I would match each rocker arm, is what I was showing you guys in class, so that each one would come down perfect. And if it was hitting a little bit this way, then I would grind a little bit of this part off and bring it till it was flat. So every one was like perfect where it was supposed to be, which I thought that was kind of cool. But anyway, so alignment is critical. What are you going to do if it's out of alignment? There's nothing you can do. And in a lot of ways, there's not much I could do. You know, thankfully, I had equipment that would rebore stuff. So it's like if I had the seat was a little bit out, and when I cut the new seat, it guided off the boss, and so it would just put the new seat where it's supposed to be, regardless of where it was before. So it made life a little easier. All right, alignment is critical. This is good to know. CDEF. We talked about oil consumption, and we talked about it in the sense that you want some oil to be burned in the cylinder, right? But that's not always where it comes from, because in a cylinder, especially like this one, we've got the intake port, right? Okay, so the piston is pulling down, it's creating a low pressure in here. So this is below atmospheric pressure right here, this area. Well, right up here is atmospheric pressure. So lower than this vacuum, not a vacuum. Well, in a perfect world, it draws it this way. But if you have space between the guide and the valve, it will pull the air in across this way. And what is up in here?
Oil.
Oil. So it pulls oil right down that guide and it starts burning oil. So it's a good chance you'd be burning oil from intake guides. Continental, big Continental, I don't know when they did it. I had to modify a lot of engines because I was just working in that time frame where I was getting a lot of engines in where they were pre-guides. Now you buy a Continental, big bore, they all have intake guides. But you know, back when I was doing it, it was like a 50-50 shot. Some would come in the shop, they still hadn't had guides on them, or a valve guide, the seals. So we'd put the guide seals on them. So I had to cut them down. They're shorter, put the guide seals on. So I guess I was going to put A, B, C, D, E, F, F. Yeah, because I'm skipping some stuff, so I can make sure I do this right. As guide wears, especially the intake. I should put that as intake. Intake guide wears. Oil consumption. Oil consumption may increase. As oil is sucked into intake port. Sorry to get all technical, scientific on you like that, but sucked into intake port. And G, we talked about this, exhaust. Exhaust guides are prone to coking and sticking. And that was morning sickness. There's actually a service bulletin for Lycoming. It's different for helicopters versus fixed wing. Helicopters is more critical, but they want you to actually take off the valve springs, get in there, take out the valve springs and stuff, and you do what they call the wobble test, and you use dial indicator on there, and you wobble it, and it's supposed to have X number of wobble. To be honest with you, it's just not something I did in the field because I don't want to say the level I was working at, but the position I was at, I was mostly working on engines that we took apart and did that kind of stuff. So I didn't thankfully have to do a lot of that. If we had the problem, we just pulled the cylinders and just did the whole thing. It was just faster, easier, and better. But I know if I had a Lycoming that I was running as an owner, I would not be afraid every 500 hours to pop that valve in, run the reamer through, check it, You're going to go through that with Larry. Have fun with that. Let's see, valve seats. I want to talk about these. Oh yeah, I kind of do. Valve seats, but I'm going to move over. Move over. Valve seats, where were you at? Valve seats. Now, if you're wondering why I wrote 8 valve seats twice, I'm just repeating it. Okay. Installed into Seat Boss with an interference fit. Which means the Boss is smaller than the seat. Can be changed when worn out. You don't do that very often. Guides we would change, especially if a cylinder came in the shop, chances were 90% we'd be changing the exhaust guide. By we, I mean me. Seats, not so much. I did it every day, but it was lower probability. Out of every 10, I would change 1 or 2. And you only changed them every now and then. Because you just reface them, and they're usually good to go. Valve seats. You can change one out. All right, I mentioned this to some of you. Seat and valve. Seat and valve have an interference angle. And by that, I mean, so I've been telling you that the valves are 45s and the seats are 45. Okay, that's not really true. They have an interference angle that is off by 1/4 to 1 degree. They call it for better seating. For better seating. And honestly, right, I don't remember, but it was like, I want to say, and you have to look at the manual, you cut the valve at like 44 degrees, and the seat for the valve, and the seat at 45. That's an example, right? You have to look at the manual how they want it done. So that's an interference. It's not exact. They don't want them both 45s. Now, to be very honest with you, we didn't do that in my shop. And I still kind of don't believe in it. And it's not that I don't believe in it. It's that good luck getting them both at exactly 45 anyway. There's so much slop in the stone and the cutters and everything. It's like if you set them both at 45, you're going to be off by a degree no matter what. So you're automatically going to get it. So it wasn't like it's something that it really worked really hard to get. So it kind of happens anyway. So hey, good news. I didn't get them both at 45. All right. This is kind of a big deal. You hear people talking about it. They call it triangle seats or 3-angle seats. So some seats. And some people make a big deal about doing this, have 3-angle cuts. Angle cuts. All right. And they would say it provides better gas flow. Well, to some degree. So if we took a look at a seat, right? So this is a seat, and they kind of usually look about like this. Like that, right? That's the valve seat. Everybody follow what I'm looking at? Because, it's hard to draw 3D. Okay. So we got one right there that's, I got that one at 45. We could do, if we did a little shallower, okay, there, which one is that? Intake, all right. So right there, that's how many degrees? 30. All right, so what they say to do then is to do a 30. It's kind of not a different color. 30, and then you do another angle right here and another angle right there. So you got 30, 15, and 45.
Is that just to make it as smooth as possible, I guess?
Well, I'll kind of explain why I did it. Exhaust, you would have the 45. and then up here you'd have a 30, and down here you do a 60 or 75 degree. I did it all of the time out of necessity. And so, and I showed you guys, so if I take a look at a valve face right here, I want to look, if I can draw this on here. That's kind of hard. So if I'm looking at the face right dead on, right, and I get this frosted appearance in there, and let's say I lap it in, and I've lapped it, and the lapping is right down here at the very edge of that. Okay, I don't like that. That's not good. It's way down here at the edge. Now, if it's way down here at the edge, especially on these thinner valves, it tends to, you don't have much material there. And I want to say it just kind of hammers it a little bit more. And so I need to move that this way. And so where is it hitting? It's hitting around this area right here up at the top. So if I use a 15-degree stone and I knock that out, I call it topping it, it moves this all back a little bit. So you have to polish it out, fix it. And then it tends to move it back towards the center. Right? So it moves it in this area right here. But if I had it in this area right here, way in the back, that means it's sitting in this area over here. And so if I use a 45, and I call that bottom hit because it's down the bottom, hit the 45 and knock it off, it moves it back that way. So I do whatever I can to bring it in the middle. And I want about, this is just me, about 1/3 here and about, I don't know, 1/3 here and about 1/3 in the middle. And I cheat a little bit towards the down here, this area. Anyway, I just want you to know that people talk about their tri-cut seats. Well, they say it does provide better gas flow. I don't really know how cutting just a little tiny notch there and a little tiny notch there really is going to make that much horsepower difference. Honestly, I mean, if you're that worried about power and stuff, I'd start by maybe not eating that donut in the morning and then go from there.
And that's exactly what you're talking about when we're doing the valve.
That's exactly, yep. Maybe Allison or straight cut. Straight cut seats. And if you remember, I showed you the picture of the Allison. Allison has a step with an interference fit of the smaller diameter and loose fit of the larger diameter. This keeps the head from cracking. This helps prevent head cracking. All right. Story time?
Yes. I love story.
Yeah, you shut up. So we had a Cessna 140 come into the shop. And it was a really cool Cessna 140, and it had normally Cessna 140s come with a C85, 85 horsepower. This one had been modified. They put an O200 on it. That means you put a vacuum pump on it. Instead of 85 horsepower, you bump that puppy all the way up to 100 horse. And I know, and you had a special paint because it just peels right off the airplane. You have so much power. Anyway, I did the annual on it, and I had a low cylinder. So I went to the guy in the cylinder shop, and I said, hey, one of the cylinders, it's, I got bad compression. He's like, don't worry, I'll go out there, I'll take it off, pop it in the cylinder shop, I'll fix it up, I'll put it back on for you. So he does that. I change out the ignition harness, or I don't remember what else I did. I don't think I did the ignition harness. did a bunch of other annual leaf stuff on it and various other things, and finished it all up, and I test run it, and that thing ran pretty sweet. I'm a Cessna 140 guy. I learned to fly in a Cessna 140, so I always kind of had a sweet spot for them. I like this one. It was yellow and white. Yellow and white. It was orange and white. Because that's part of the story. When you get old and you're telling a story, the colors are part of the story. So anyway, the pilot owner, nice guy, and he, and I was always concerned after an annual, hey, give me a call when you get back home, because I think he kept his airplane over at executive, and he calls up and he says, the thing ran great. Ran a little bit rough at higher RPM. Well, it's just got to kind of break in, and give it a chance. And he called the next week. He says, man, I got to tell you, Kevin. He goes, this thing runs really rough. He goes, I get to a certain point, certain RPM, and the thing just wants to shake itself out of the airplane. I'm like, what? That doesn't make any sense. Well, bring it back. Let me take a look at it. He brings it back down, and I'll ground run the crap out of this thing, and it just runs sweet as can be. I don't know, it just doesn't make any sense. Well, I don't remember the whole story, how it went, the timeline, but I know, I guess we could change out your ignition harness. It sounds like it's missing at higher RPM, because ignition, the higher RPM you get, the more the manifold pressure is higher. That's more stress on the spark plug, more stress on the ignition system. That's when they're prone to breaking down. So, we did that, and it's expensive, charge this guy for a new ignition harness. It was working when it came in. It doesn't work. And he keeps telling me about this. I'm like, look, I'm running on the ground. The thing is running fantastic. He's like, well, then I'm going to take you for a flight. So we get in the airplane. He takes off. He hits some point. I'm like, shit, don't do that, man. It scared the hell out of me. He goes, this airplane's going to... It was the weirdest thing. It's like you could not duplicate it on the ground, but in the air you could duplicate it every freaking time. And it was scary. It wasn't like this sudden or subtle little shaking. It was, this got your attention, this thing's coming apart kind of a shaking. And then you back off and it would smooth out real nice. And I just troubleshot this thing to death. I think I looked at the car, because when you do troubleshooting, it's fuel, spark, air, mechanical, right? And so you're going through every one. Okay, well, the spark, I've done the magnetos and the harness and the spugs and everything is fine. The carburetor is just fine. It's, on and on and on. And I'm just beside myself. And so the guy in the engine shop, Tim, we were at lunch one time. I'm just like, Tim, man, you got to help me out, dude. He said, what the hell would cause a Continental 0200 to shake like that? He goes, that plane? I said, yeah. He goes, well, first of all, Kevin, he goes, your mistake is it's not an 0200, it's an 85 because it's out of a Cessna 140. I said, no, Tim, it's an 0200. It's been type certificated for a different engine. He goes, oh, shit, Kevin, I'm sorry. He goes, I thought it was an 85. Ooh. Difference between a C85 cylinder and an 0200 cylinder is an 0200 cylinder has 3 valve springs per side. He put in 2. So at a certain RPM, the valve floated. And that means that it didn't close all. It set up a harmonic in there between those springs. And it just caused that problem. And I troubleshot that thing for a week and a half and charged the customer thousands of dollars. I don't know what happened.
Why was that not, you couldn't duplicate it on the ground if it's a valve spring issue?
Okay, good question. One of the one of the facts about a fixed pitch propeller is that on the ground you will be a long way from the high RPM mark. That's called the static RPM. So if the airplane is designed to go to 2750 with a fixed pitch propeller on the ground, feet locked, give it full throttle, it should go to about 21, 22. It depends on the prop. And it's right in the type certificate data sheet. Even it's part of the certification of the aircraft, what that RPM is. So what would happen is we would take off, and then if you do that in a fixed pitch propeller, just take your feet off the brakes and start rolling, the RPM starts coming right up.
We talked about that a little bit previously.
Yeah, so that's exactly what it was. We were just in the air and moving forward at a rate where he could get those RPMs.
That's crazy.
Yeah. So it was obviously something I have never forgotten. So valve springs. just missing two, and they're little tiny springs in there, because you got to think about what you guys are working on. You got the big one, then you got the inner. This one had to fit in between all of those. It's the third one down. They're tiny little springs. And it made all the difference in the world. So valve springs. Well, what are they supposed to do? They're supposed to close the valve. I got too much in here again. Valves open and close about, depends on the RPM, 20 to 30 times a second. I have not done the math to verify that. Times, I think I just read it somewhere, a second. Or maybe I did.
Stand there with the clicker counting?
I did, I counted, yeah. What is it? Oh, I did do it. If the engine is running 2,600 RPM, then the valve opens 1,300 times a minute, with 1,300 divided by 60 equals 21.6. Let's see. Close the valve. I already wrote that. Keep the valve closed when not opened by cam or rocker. Well, that's redundant. Usually a set of 2 or 3 springs. Often they're counter wound. So counter wound. In other words, if one spirals up this way, the other one's going to spiral up the opposite way.
Do you ever see just one spring, or is it always 2 springs?
I've never seen one.
Okay.
Oops, sorry. It'd be C, because I skipped something. Dampened, they are dampened. Dampened or progressively wound. Not always, but often. That means the bottom is wound tighter than the top.
Just 2 hours.
Yeah, well, no. Yours is the other way.
Oh, it is?
I saw how you put it together. Just kidding.
Don't do that.
Some of you decided every other cylinder is going to be dampened the opposite, so that's why I wanted to bring that up. A, B, C, D. So the multiple valve springs, M-U-L-T-I-P-L, multiple springs prevent valve float. And that has nothing to do with root beer and ice cream.
Use stronger springs.
You still can get harmonics built up. And I don't know how that would work, because now you're going to put more pressure on the valve train going backwards. Yeah. So, well, the rocker, which is then the push rod, which presses against the cam lobes, and so. I have in here held in place by lower spring seat, upper spring seat, valve keepers. I'm going to change that to replace keepers on removal. That's the one thing I regret, is that this overhaul we're doing, it's teaching you some bad habits, and that we're not able to take this and throw it away. You know, you can't take your keepers and watch them physically hit the garbage can and go, yeah, I remember that, we don't reuse those. Or, you know, the tab that holds the cam or the crank gear, you know, you guys are reusing it, and it's like, no, that should be thrown away. A lot of this stuff never reused again.
That was that one really chewed up tab that I kind of showed you.
Yeah, that's why I need to order just a bunch of them. I don't think they're that expensive.
When you use the term valve float, does that mean that it just it doesn't stay in contact with the spring?
With the seat.
Moving freely then?
So, like, instead of it following the valve rocker up and down, it can actually hit it and make it bounce back down,
Oh, okay.
and then start doing a little bounce thing on its own.
And it won't see.
It won't seat. So when it should be up on its seat, it's not. Because number one, either the rocker arm hit it and it actually just pushed it so far away that it's going to be open longer than it should be, or that it's going to resonate up and down a little bit, start bouncing a little bit.
I don't.
Yeah.
When you say it pushes it further, does that mean it can just be further into the cylinder and that's what causes it to stick?
No, it doesn't stick when it does that. It just stays open longer than it should.
I don't know if it was already asked. It might have been, but are airplane engines usually interference? Like, will the valves go into where the piston will go
Oh.
in the center?
I don't actually know. I think they are.
So
'Cause
valve flow can be pretty
yeah, oh yeah, yeah. But like I said, I've never heard of it. Just that one time. It's the only time I've ever heard of it. So, but yeah, but a lot of the pistons they're dished out, so they actually have a little spot for the valves to go. So I'm assuming that it would be an interference at that point. All right, we good with valves? I think I told you everything I want to tell you about valves. Let's work our way back down now.
switching gears.
The valve train. Now, before you get real excited, this is not like the dinosaur train with valves. Valve train. I'm talking mostly to Tobias because he's one of my guy in here who's still watching Dinosaur Train at home.
Dinosaurs are cool.
Tell me, what's your favorite one?
I kind of like the Stegosaurus.
Yeah, that's what I figured. Yeah, it's the one I could think of too off the top of my head. Okay, valve train. That's what makes the valves open and close. Well, technically the valves are part of the valve train, but we covered that. Now we'll start at the beginning and work our way back to the valves. So we start with the camshaft, or the cam. I should say cam because not all engines have camshafts. Some of them have
Hydraulics.
Cam rings.
cam rings. Good, keep throwing out stuff. You're gonna get right sometimes. There.
Is that wrong though? Do they not use hydraulic? Never?
Oh yeah, absolutely. Yes, most of them do. Cam. So let me see. I changed my notes around here, so I gotta be careful here. So two types of cams. One would be the cam ring, because you said shaft. Who uses a cam ring? Radial engines. And the other one is the camshaft. Camshaft. And a camshaft, it rotates at 1/2 crank speed. I like to say that the camshaft is kind of the brains of the operation. The crankshaft is just the brute force, right? Because as it goes around, it really doesn't give any thought to what, well, let's be honest, the camshaft doesn't have a brain, so it's not thinking either, but stick with me. The crankshaft doesn't give much thought as to is it an intake, an exhaust, a power. It's just going around because it's just a big dumb brute, right? That's its job, make the piston go back and forth. Now the camshaft, that's the brain of the operation. It's kind of like a marriage, me and my wife. I'm sort of like the camshaft of the family. She's more of the crank, she's the camshaft. You know, you got to figure out, you know, what's Kevin doing? Well, he's compression, so I guess I got to keep the valves closed, you know, and then get up there. It's like, all right, now it's spark plug, and then, you know, it's going back the other way. Now it's like, whoa, okay, exhaust time, better open. You know, Kevin's going that way, got to open the exhaust valve. So, you know, it's always got to do the thinking and get in there. So, anyway.
Who's the sludge tube?
What?
Who's the sludge tube?
Where's the sludge tube?
Who's the sludge
Who's the sludge tube?
Kids.
The kids are my sludge tubes. It's the damn dogs. They're always sludge tubing on my stupid floor. All right, camshaft. Rotates at half speed, and it's obviously used on everything other than radials. Two types. Talking about the cam. So you got point 2 right here. Utilizes lobes to press on followers. Well, I don't have to show you what a follower looks like because you have measured them till you're sick of them.
Not me.
Your grade will reflect that. So, oops, what do I got? Why am I missing one? I'm gonna freak out somebody. That's because I changed stuff around. All right, I guess remember this. This is B3 then. 1, 2, 3. Follower. Opposed engines. Opposed engines have a shared intake lobe. Why is that? I think it has to do with the way the cylinders are just lined up and opposing each other. It worked out that way. So a four-cylinder cam, so you know what I'm talking about. Four-cylinder cam has 6 lobes. That would be 4 for exhaust and 2 for intake. Often, the intake lobe is wider. It's because it has to hit 2. When you're looking at a cam, the journals, the lobes, and gear teeth. Because I'm thinking of Lycoming right there. Lycoming, they don't do the 2-piece like you guys took your crankshaft. Geez, time to go. Took your camshaft gear off. You can't do that anymore. They're 1 piece. They're all built together. And when you get it, most of it is all copper colored, except for the journals, the lobes, and the gear teeth. And so what does that tell me?
Nitrated.
It's nitrided. Those items are nitrided. So,
Why
and that's,
is the intake wider?
I think it has to do with just the alignment to make sure, because they're not perfectly maybe aligned. That's all I can think of.
Okay.
And not all of them, just some of them. So, what's that?
Maybe the valve timing?
It's not timing. No. So I wrote this: copper coat. Copper coat prevents nitriding or carburizing. Carburizing is another form of hardening. So, oops, and gear teeth are carburized. Carburized. There we go. All right.
Is carburized just another word for nitriding, or is that different?
It's. I think they use more carbon in it. I don't know the exact process. It's a hardening. That's what I know. And so tomorrow, this would be IV. This would be radial engines. Radial engine cam rings, to be specific.